In our yeast module, we used Saccharomyces cerevisiae to study mutagenesis and to see which genes are involved in the adenine biosynthesis pathway to produce adenine in yeast. Today, we will be reviewing all these concepts with the fellowship of the AID pathway. I hope you all enjoy. Yeast of middle yeast. The pathway begins with me and with the upstream genes who act first to set the journey in motion. I am made forward. I start the committed step. But my legs have grown weary, and I can no longer bear to carry the burden of the pathway's early intermediates. Those upstream steps that must be converted into other substrates before air ever appears. Thus, I am passing the task to Frodo, Aid 2, who works downstream of me. Frodo will thus carry the air intermediate, continuing on the pathway where my role ends, to convert air into care. Frodo, you are summoned at once. Thank you for the ring, Gandalf, also known as the air intermediate. I will do this, even though it is dangerous, and I may be the reason we turn bright crimson red, if I should fail to convert air to care. But it is my duty, as Aid 2. Frodo, you cannot do this all alone. Let me help you. I'll help once Frodo passes it to me, because I work downstream of Aid 2, aka Frodo. I will take the care intermediate from Frodo, Aid 2, and convert it into Psycare. Together, we'll carry on to convert air to Psycare, and so that we may succeed in eventually synthesizing adenine to save Middle Yeast. But beware, if either of us falters in our task, the ring's burden will linger as air or care, and Middle Yeast will glow bright crimson red. Alright class, let's review what we just saw. So, in wild-type yeast, Aid4 is the first gene involved in initiating the synthesis of adenine. Then, later in the pathway, two genes involved in the completion of the adenine synthesis pathway are Aid2 and then Aid1, and they act in sequence. Specifically, the Aid2 and Aid1 genes act in order to process the air intermediate and produce adenine. Thus, in what we just saw in the story, Gandalf is Aid4 and he begins the quest, but it is Frodo, Aid2, and Sam, Aid1, who must carry air forward, transforming it step by step until adenine is finally forged. However, in our lab, we put our yeast to the test, and we did this by exposing our yeast plates to UV light. UV light acts as radiation, leading to mutations. Most importantly, if these mutations strike and fall on the genes of the AID pathway, the pathway can be disrupted and thus ultimately change the colony's color. Let's see how this affects our friends and Frodo. What is this light? I cannot convert air. I am mutated. The ring, it overwhelms me. I have the ring. Middle Yeast is doomed. Your colony turns red. As we just saw, when Aid 2 fails and cannot convert air, the air will therefore build up immediately. Then air oxidizes into a red pigment, as we just saw on our colonies. Master Frodo, I can no longer bear the ring. Alas, I too have been mutated. I cannot convert the care that intermediate Frodo, Aid 2, would have produced from air. I cannot convert it to Psycare, and I cannot continue on the pathway either. Frodo, I can't process it. My role in the pathway ends here. I have the ring again. Middle Yeast, you are doomed for not being able to convert your intermediates. Soren is right. Middle Yeast is honestly pretty cooked. Even though Aid 1 comes after Aid 2 in the pathway, if it fails, care will build up and the colony will turn red. We are the council of upstream genes, Aid 2. If any of us fails, air never forms to begin with, meaning you will never receive the ring, Frodo, Aid 2. Let's see what just happened in that sketchy scene with the Council of Genes. Basically, we're seeing how if a mutation occurs upstream in Aid 4, 5, 6, 7, or 8, it will mask the mutation of the red phenotype of Aid 1 or 2, even though the yeast is still an auxotroph because it cannot make adenine, and thus it will require adenine to be provided externally in the agar medium in order to persist. In simple terms, this means two things. First, air will never be produced in the first place, which means there will be no red pigment. And secondly, most importantly, it means you will not be seeing me again in that red morph suit ever again. Seriously. I don't think I can put it on again. So, in this case, we see a clear case of epistasis, where an auxotroph appears cream-colored even though it cannot produce adenine. The fellowship still fails to forge adenine. However, since the colony wears a cream wild-type looking disguise, its true auxotrophic fate is masked. So class, to summarize what we saw today, we reviewed some of the most incredible concepts that we saw earlier this semester. First of all, we went over how the adenine biosynthesis pathway functions in sequential order from 8.4 to 8.8 to 8.6 to 8.7 to 8.2 and finally to 8.1. Further, we saw how these all must function correctly to synthesize adenine and prevent the buildup of any intermediates. Then, we saw how you can even have a white colony that still cannot produce its own adenine. It's tricky, but it's important to recognize that the whole pathway is crucial for adenine to be synthesized. And if there's any failure from the genes earlier in the pathway, how we saw with the council of genes, such as 8.4, 8, 6, 7, or 5, then air won't even be produced, and the colony has a cream color, yet it is still an autotroph. Finally, for all of these concepts, it's important to recognize that we use UV mutagenesis to induce radiation, which ultimately led to the mutations that we saw on our yeast plates. Thank you so much. Hope you enjoyed. Genetics class, you shall not misinterpret epistasis.